Hello everyone and welcome to my channel. This video is going to be an introduction to hardware security by using some affordable tools and also an easy target, which is this TP-Link wireless router. So in the video we are going to see how to evaluate our target and how to find some information about it online. Then we would see how to extract the firmware via the tools that you can see here, and also how to access the Linux terminal that's running on the device. The target I have chosen is a cheap wireless router. It's a TP-Link TL-WR841N, which is a 300 megabits per second router. And the reason I have chosen this specific model is that this is one of the easiest targets for an introductory course or introductory video on hardware security, and you will see later why. And it's also cheap, and also all the other tools that I have chosen are easy to use and easy to find and also affordable. So the first step when doing any sort of security test, whether software or hardware, is to gather some information about your target. In this case, our target is a device. So we want to know, even before opening the case or connecting to the device, we want to know what sort of chipsets it has inside, what is the operating system it is running on, does it have a radio inside for, of course, this specific device has radios because it has like antennas, and you know that it's a wireless router, so it's running on 2.4 gigahertz. But in some other cases, you want to know whether that specific target has any radio, any receiver or transmitter or not, because then you would also want to evaluate the security, the wireless security of the device. Usually devices that have wireless transmitter or wireless receiver or both that are sold in US have a FCC ID printed on the back. So if you, this device also has an FCC ID, so you can go to the fccid.io website, look it up and get some information. For example, before even opening the device, you can see some pictures of the inside of the device on that website, also some other information. So we are not concerned with those information for this video. So let's open the device. It just has two screws. I have opened them already, so this is easy. There is nothing on the other side of the PCB, so we are going to only examine this part. As you can see, we have three chipsets or ICs here. This is the main chipset, which is called SoC, System on Chip. Don't confuse it with Security Operations Center, which is also called SoC. But this is System on Chip, which contains a microprocessor and some other stuff, for example, USB microcontroller inside and some other devices. So it's more than a processor, which is the heart of this system. I think the clock is around, 600 megahertz. This is the RAM. I think it's about 32 megabytes, and this is the ROM, which contains the firmware or flash, and we are going to extract it later in this video. How do I know that this is the flash, this is the CPU or SoC, and this is the RAM? Because they have this part number printed on them, and you can look them up online and see their data sheets and much more details about them. So to obtain the firmware of a hardware target, to be able to do reverse engineering, you have multiple options. The easiest one is to download the firmware update file from the vendor's website. In this case, that's also available on TP-Link's website, but suppose that we don't have access to that, then you can connect to this device with a serial interface, which we will see later in the video, and copy the files one by one, or you can dump the whole firmware, download the whole firmware via some, download is not a proper term here. Maybe I should use extract with some tools that we will see later in this video as well. So what are the other use cases for having direct access to your device or being able to read or write the firmware directly on the device? It is one of the ways to fix bricked devices like laptops or hard disk drives if they have a faulty firmware or some similar reason that need a flash rewrite or a firmware rewrite, which is usually not accessible to regular end user, but you can do that with specific hardware tools, as we will see later in the video, or you can remove the BIOS password of some laptop models. You can remove the limitations of some hardware devices like drones that have, for example, altitude limitations, and you can bypass or override those limitations by overriding the firmware. So a question may come to your mind, which is, how do we write on a chipset which is called RAM, which stands for read-only memory? So it's going to be only read-only, right? Well, this is a specific sort of RAM, which is called EEPROM, or electrically erasable and programmable. So this is a RAM which, yes, it's read-only, but can be erased and reprogrammed using some tools. Usually they are called programmers, or for example SPI flash programmer, as we will see later. In this video we are going to work with two protocols or two interfaces. One of them is UART, which is a serial interface to access to the Linux terminal. The other one is called SPI, which we are going to use for dumping or extracting the firmware. So first, what is UART? We need to connect to the Linux terminal. So we need to connect this device somehow to our laptop. But how do we do that? We should look for serial interface on the device. Usually we are looking for UART, which stands for Universal Asynchronous Receiver Transmitter. And in a majority of cases, it's 4 pins or 4 jumpers unpopulated on the PCB board. So if you find 4 pin outs, 4 jumpers, or 4 holes on the PCB close together, it's most probably UART. So here, I think it's visible in the video, we have these 4 pin outs or 4 jumpers. And fortunately in this case, there are printouts close to them on the PCB. So the first one is VCC, the second one is GND, the third is RX, and the last one is TX. VCC stands for the voltage, and GND is ground, and then the receiver and transmitter. We only need 3 of these 4 pins. The ground, of course, we need to connect the ground of this device to our interface. And then also we need the receiver and transmitter to receive data from this board and also transmit data to this board. So what is the tool that we need? It's called a USB to UART, or it's a UART adapter or serial adapter. So it has many names. It's very cheap. One side is connected to your laptop. The other side is connected to these 3 pins via jumpers. And one thing is important to bear in mind that, so GND is connected to GND, right? RX of your adapter is going to be connected to the TX of your device, and vice versa. RX of the device is going to be connected to the TX of your adapter. So what I'm going to do is connect the GND to, I have multiple devices here that can be used for this purpose. I will use this easiest one, or the simplest. So I'm going to connect the GND to GND, RX to TX, and TX to RX. But one more thing before continuing. Some of these adapters have a selector jumper, which has to be set by the user, which is you, to specify the logic level or voltage level of the device. Usually we have 3.3 volt or 5 volt logic level on the board. This device doesn't need that. It doesn't have a switch, but this adapter has a switch, and if you don't specify the correct voltage, you may harm your adapter or your device or both. But we don't know which voltage level this modem is using. How we can find out? We only need a multimeter. We put it on the DC voltage, we power on the target device, and we measure the voltage between VCC and ground. As you can see, it's 3.3 volt. So we know the voltage level for this target. One more thing before I connect the device to my laptop is that what if we don't have these printouts on the PCB? I mean, in this case, TP-Link has printed the because we need to know which one is RX and which one is TX. Ground is very easy to find. If you don't have these printouts, you can either play with the, it's just 2 pins, right? Just play RX to one and TX to the other, and if it didn't work, connect the other way around. But you can also use an oscilloscope or a logic analyzer to see which pin has some activity. RX is like a passive pin here. It doesn't do anything because it's waiting to receive something, and we are not transmitting something to this device. But the TX is the pin that has some activity on it, and then it's like easy to find which one is TX and which one is RX. So I'm going to connect the GND to GND, the brown, and then these two also to RX and TX. Be careful, so red is RX, red should be TX here then. And so I'm going to connect this to the laptop and then power on the modem and see what happens there. After it's connected to the laptop, let's see if we can detect it. Yep, it's here. So let's also find the exact device path, which is here. So the only thing left to do is to run the sprint command. And we provide the command with 2 arguments, the path to our device and also the baud rate. The baud rate is very important. If you provide a wrong number, you will see garbage printed in the screen. So there are multiple ways to calculate it or find it out. For example, you can use a more advanced USB-to-UART controller to automatically find the baud rate. I will link to one of those in the video description. Or you can calculate it via some other method. So I'm going to run the command and then connect the power adapter to the modem. So power it on and we will see everything from the bootloader up until the Linux terminal. Okay, so run the command, connect the power adapter. As you can see, this is the bootloader and other messages printed from the modem. So it's using U-boot bootloader compiled on Mars 2018. This is the RAM. So as I said earlier in the video, it's using 32 megabytes of RAM. Let's see what other information we can find here. We know the flash component or that we are going to use later for the firmware extraction is a SPI flash. This is our CPU, 580 megahertz. What else? Okay, then this is Linux, starting the kernel. I would say an old Linux version. This is the compiler and the build date, etc. The architecture of the CPU or of the system. Okay, let's just press the enter. Oh, we are in the Linux terminal of the modem. Wow. Do we have a who am I? Nope. So what do we have? Let's see. This is the root, right? What do we have in the bin? Okay, not too many comments here. We have BusyBox, which is a standalone binary which contains a lot of Linux commands. Let's see. Yes, we have these commands here, as you can see. So I'm not going to show you some more advanced things here, because then this is just software and I think you can figure it out. And I will also provide some links for more advanced stuff. I'm just going to point you to two things. First is that with this TFTP, you can copy files from the modem to your laptop. So you just need to also connect your laptop via Ethernet to the modem, and then you will use this TFTP to transfer files. And the second thing is that you can transfer a GDB server here, which is for the for debugging. Then you will be able to remotely debug your binaries directly on the modem. Yeah, so this is it. This is our first demo. Let's do the firmware extraction. Okay, so we learned how to connect to the Linux terminal on this device, and now we are going to see how we can dump the whole firmware and then copy that to our laptop and then do some sort of reverse engineering on the firmware there. So for this purpose, we are going to use a programmer, which in this case is, the model is CH341A. So our IC, our RAM chipset, has 8 pins, and we are using this specific like alligator clip to connect to it, and then connect the programmer to our laptop, and then we will dump the whole thing. Just be careful to you have to know which pin is the pin number 1 or the first pin, which is usually or almost always specified with a small dot. You can see a small dot here, or you can see a small dot here. So that's the pin number 1, which in our case on the alligator clip is also specified with a wire with a different color than all the other wires. So we will connect it. Let me make sure that it's correct. Yes. And then let's see the rest of the video in my laptop. Connected the SPI flash programmer to the board, to the EEPROM, and also to our laptop. So let's run the command flash RAM with these two arguments. We specify the type of the programmer that we are using, and also the file name. And yes, as you can see, the flash chip is found, which is made by this company, Winbond, and it is a 4 MB SPI flash. So we should wait like a few minutes for the whole firmware dump or extraction process. I'm going to skip this, and because I have already dumped it in my other machine. So let's run binwalk on the file that we have extracted. As you can see, the binary file that we extracted from the chipset contains a bootloader section and a compressed data section, which we have to examine to see what's inside, and it also has a SQHFS file system. And as you see, I said earlier that MIPS systems can be either little endian or big endian. So in this case, our system is little endian. Let's extract the contents of this binary file. Okay, this is the extract folder, and as you can see, all the files that exist on inside this modem and inside the firmware are already here. There are so many HTML files, JavaScript files. Where is the actual? Okay, so as you can see, squashfs is here. So let's see what's inside the file system. Okay, see, this is the Linux that is, or this is the files of the Linux OS that's running on the modem, and you can examine them, you can reverse engineer them. I hope that you have enjoyed this video. I know that I had to skip a lot of things, there are a lot of abbreviations, there are a lot of protocols, a lot of advanced things that I didn't mention or I had to like quickly jump through. So I hope that you have learned something. Please let me know if you have any questions or if there are any problems with the video. You can approach me either via the comments in this video, or you can also find me on Twitter. You can find my Twitter handle in the video description. Thank you very much for watching.